It's the world of sterilization and disinfection methods.
Absolutely. Yeah, it's all about those tiny little microbes.
Yeah, right. And we've got some amazing notes here, and I'm really excited to kind of unpack this.
Yeah, this should be fun.
Yeah, and it's one of those things that we all kind of do every day, but we don't always think about.
Right? We take it for granted.
Exactly.
Yeah.
So we're going to learn about how we keep these microscopic invaders,
Yeah.
under control.
Under wraps.
From
Yeah.
the everyday things to some really intense methods.
Oh, yeah, we're going to the extremes.
Yeah, we're going there.
All right.
So let's kick things off with the big kahuna of sterilization.
Okay.
The autoclave.
Yeah.
Have you ever heard of this thing?
Oh, yeah, it's like a staple in any lab or hospital.
It's intense, right?
Yeah.
It's like a pressure cooker.
Yeah.
On steroids.
Yeah, exactly.
Yeah.
15 pounds of pressure for 15 minutes at 121 degrees Celsius. That's hot.
That is seriously hot.
That's how you know it's working.
Right. And that's what it takes to achieve true sterilization.
Right.
Which means it obliterates
Everything.
every single living thing, even those crazy resilient bacterial spores.
Yeah, even the spores.
Spores always sound so scary to me.
They are pretty tough little guys.
Why are they so hard to kill?
Well, they have this really thick outer shell that's designed for survival.
Oh,
It can withstand extreme temperatures, dryness, even some harsh chemicals.
oh, wow.
And if you don't get rid of them completely, they can germinate later and cause all sorts of
Oh,
problems.
that's not good. Especially in hospitals and stuff.
Especially in medical settings, yeah, where you really need things to be sterile.
Right. So just boiling water on the stove doesn't cut it.
Boiling is good. It'll kill most of the bacteria that are actively growing.
Okay.
But those stubborn spores,
They can survive.
they can hang on. Yeah. So that's why we have the autoclave.
All
It's the gold standard for a reason.
Makes sense.
Yeah.
Right. So that's the most hardcore method. But what about something like pasteurization? We see that on milk cartons all the time.
Pasteurization is a really good example of disinfection.
Okay.
So it uses heat, but not as intense as the autoclave.
Okay.
About 72 degrees Celsius for just a short time.
Okay.
And it's designed to kill the most dangerous pathogens in food, but it doesn't achieve complete sterility.
Oh, right.
It's like a targeted approach.
Right. So it's not going nuclear.
Exactly. You want to get rid of the bad guys, but preserve the quality of the food.
Right. Right. So you don't end up with weird tasting milk or something.
Exactly.
All right. So heat is great, but sometimes it's a problem, right?
Yeah.
What about delicate instruments or lab materials that can't be boiled?
Right. You can't just throw everything in a pressure cooker.
That's where dry heat sterilization comes in, right?
Exactly. So it uses high temperatures, but with hot air instead of steam.
Oh, okay.
And it takes longer, but it gets the job done.
So it's like choosing the right tool for the job.
Exactly.
Depending on the material and how much destruction you need.
Exactly. Some things you want to obliterate and some things you just want to clean.
Right. And then on the other end of the spectrum, you have incineration.
Talk about overkill.
Right. Just burning things to ashes.
Yeah, no more germs there.
When would you ever need something that extreme?
Well, when you're dealing with biohazardous waste,
Oh.
contaminated lab materials, medical waste, things like that,
Okay.
you want to make sure there's absolutely nothing left alive.
Right. No room for error.
Nope. And it's also used for sterilizing really small metal objects, like those tiny loops they use in microbiology labs.
Okay.
Incineration is definitely the nuclear option.
Wow. All right. So we've talked about heat and burning things, but let's switch gears to something a little gentler, filtration.
Filtration is a cool method.
Yeah, it's like using a superfine sieve to remove the microbes, right?
Exactly. You're physically separating the microbes from whatever you're trying to sterilize.
Okay.
So you use a filter with these tiny pores that trap the bacteria and spores.
Oh, okay. I immediately think of those HEPA filters everyone's using these days. Is that the same concept?
Yeah, absolutely. HEPA filters are a great example.
Okay.
They use fine fibers to trap particles from the air, including bacteria and viruses.
Cool. So it's not just about liquids then.
Nope. Air can be filtered too. And in labs, filtration is used to sterilize liquids that would be damaged by heat,
Oh, okay.
like certain types of growth media that they use for bacteria.
That makes sense. All right, let's move on to the more high-tech stuff. What about using radiation to kill germs?
Ah, you're talking about UV light sterilization.
Yeah, those cool blue lamps you see in labs and hospitals.
Yeah, those are emitting UVC radiation.
Okay.
It's a specific wavelength of UV light that's really good at disrupting the DNA of microbes.
Oh, wow. So it's like scrambling their genetic code,
Exactly, they can't function anymore.
and that's it. They're done.
Yep. UV sterilization is becoming really popular because it's fast, it doesn't use heat, and it doesn't leave any residue.
That's all.
It's even used to disinfect drinking water in some places.
Wow, that's amazing. All right, so we've covered heat, we've covered physical removal and radiation.
Yeah.
Let's talk about the chemical warriors.
Yeah, the chemical disinfectants and antiseptics.
Okay.
These are substances that kill or inhibit the growth of microbes, but they don't always sterilize.
Okay, so something like alcohol, which we all have in our hand sanitizer these days.
Alcohol is a classic example,
Right.
but the concentration really matters.
Okay.
For ethyl or isopropyl alcohol to work well against most bacteria and viruses, you need a 70 to 80% solution.
Oh, cool.
And even then, they don't kill those tough spores.
Those spores are like the superheroes of the microbial world.
They really are.
All right, what about bleach? It seems like everyone uses bleach for everything.
Bleach or sodium hypochlorite is super effective against a lot of different microbes,
Okay.
including some really nasty viruses like HIV and hepatitis B.
Oh, wow.
But it's important to use a fresh 10% solution every day because it breaks down over time.
Good to know. All right, last one, formalin.
Formalin is a solution of formaldehyde, and it's powerful stuff.
Okay.
It's used to preserve biological specimens,
Oh,
but it can also be used as a disinfectant,
okay.
although it's not as common these days because of safety concerns.
Yeah, formaldehyde doesn't sound like something you want to mess around with.
It's a reminder that effectiveness and safety have to go hand in hand.
Right, absolutely. Well, we've covered a lot of ground here.
We have.
It's amazing to think about all the different ways we keep these tiny invaders at bay.
Yeah, from simple boiling to high-tech radiation and powerful chemicals.
We've got a whole arsenal,
We do.
and it's more important than ever as we face challenges like antibiotic resistance.
Absolutely. Understanding how to control microbial growth is crucial for public health.
Right. Well, thanks for taking this deep dive with us.
It was my pleasure.
We hope you learned something new and maybe feel a little more empowered to face those invisible foes in your own life.
Yeah, knowledge is power.
Right. Keep exploring and stay curious.
Absolutely.
See ya.